Hello, everyone. Thank you for joining us for today's webinar on Pytes commercial energy storage. Just a few quick notes before we get started. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, feel free to use the Q&A button at the bottom of your screen to type in your questions. These will be monitored. And it is my pleasure to introduce today's presenter, Logan Bacher. Logan graduated from Northern Arizona University with a bachelor's degree in both mechanical engineering and Spanish. He has been in the solar and storage industry for over 9 years now. And before joining Pytes, he worked as a solar applications engineer where he focused on system design, equipment sales, and technical support. 2 years ago, he began his role as product manager with Pytes. And without further ado, I will pass it over to Logan to get us started. Thank you for joining us today, Logan.
All right. Thank you so much, Tatum. I'm excited to be here, and thanks everybody for joining us as well. Always love doing webinars with Charge Solar, and yeah, strengthening our partnership any chance we get. So yeah, we'll dive right in. I think we've got the Q&A active. So if you guys have questions during the presentation, you're welcome to drop those in there. We'll do our best to get to those during the slides. And then once we're all done, I'll try to save some time for everybody at the end, and we can have some more Q&A. So yeah, we'll get going. So I'm Logan. I'm product manager for Pytes USA and Canada. We're going to be talking today about C&I, commercial and industrial energy storage and installation. I do want to do a quick little reminder before we kick it off. We can provide NABCEP credits, CEUs, for this presentation. It would be equivalent to an hour of continuing education units. So if anybody watching needs that or is interested in that, reach out to me or Tatum, and we can work on getting you guys all squared away with the NABCEP credits. So today I'm going to go over a little bit Pytes intro, just kind of explain who we are, how we got started. We'll focus the majority of the presentation on C&I energy storage, why it makes sense, and introduce our product line. I've got a few case studies towards the end, as well as some details about our certified installer program, Pytes Power Partners. And then, like I said, we'll wrap it up at the end there with some Q&A. So we've been partnered up with Charge Solar for at least the last 2 or 3 years now, I think. So there's a good chance a lot of you watching know who we are and what we do. But for anybody that doesn't, Pytes Group is a lithium battery manufacturer. We've actually got over 20 years of experience in the battery manufacturing space these days. Over 1,000 employees worldwide, 40 plus patents across our product line, which spans 3 different divisions. And we're headquartered in Shanghai, China, with offices and subsidiaries all over the globe, actually. So we do have a very much so a global presence, but we also maintain a very high level of local service. For the US and Canada specifically, our main headquarters is in Dallas, Texas. We've got warehouses there as well as in Los Angeles, Panama, Puerto Rico, along with other subsidiaries and offices in the Americas and then elsewhere in the world, primarily Europe and Asia. So Pytes, we actually got started in 2004 making small cylindrical cell lithium batteries for consumer electronics. So things like electric toothbrushes, flashlights, small robotics, medical equipment. A couple years later, we launched our LEV division. So that's light electric vehicles, making batteries for e-bikes, scooters, motorbikes, things like that. And in 2017, that's when we launched our ESS division, energy storage systems. So that's obviously what we're here to talk about today. We have, a pretty um, uh, diverse product lineup for both low voltage and high voltage applications, residential and commercial systems. That's kind of the main players at the bottom there. You can see in terms of what Charge Solar carries from Pytes. Kind of our flagship product for them at the moment is our V5 and our V5 Plus. Those are 5 kWh server rack batteries. V16, that's a brand new addition to our lineup and Charge Solar's lineup. That's a 16 kWh outdoor rated wall mount battery. So both of those are low voltage batteries for primarily residential applications. Charge is also offering our indoor high voltage battery. And then along with these other two models that have outdoor cabinets, it's going to be these three that we're primarily focusing on today in the webinar. So like I said, the other two divisions that kind of helped Pytes get started over 2 decades ago, still very much active today. Not too much to say about this slide other than we've worked with some very well-established, well-known companies in both of those spaces, right? And we were actually making solutions for some of these companies as an OEM, if you will, before we even had the Pytes brand name as we know it now. So we are, as I said, a OEM, original equipment manufacturer. So we do everything in-house from the design and development of the products to the manufacturing, the pre-sales, the post-sales, logistics, and more. We don't use a third-party manufacturer. We don't use a separate contract manufacturer. Everything is done by the Pytes team. So kind of a quick shot of our production line here. Actually, quite a bit of the battery manufacturing process is automated nowadays, depending on the model. Some have more automation than others, but at the end of the day, it's a combination, if you will, of both manual assembly processes and fully automated ones. So our main facility, our headquarters is in Shanghai, China. This is where the majority of our ESS products are made. I had the opportunity to go there in January and visit, and it was pretty amazing seeing behind the scenes, seeing our testing lab, our compatibility lab, every battery that comes off our assembly line. It goes through a multiple day aging process or cycle testing before we release it into the field. And then here you can kind of see some of the other processes that are involved in the production. So actually, Rob and Jeff from Charge are currently in Shanghai touring our facility and attending the SNEC Expo. So that's Rob from Charge Solar just a few days ago, I think, with our HV indoor 48100 battery. We also have a factory in Vietnam. This facility has been operational since 2019. This is primarily making batteries for our LEV division for e-bikes. But recently, largely in response to some of the tariffs and administration changes in the US, we are shifting some of our ESS production from China over to Vietnam to reduce some of those tariffs between China and the US. Obviously, that doesn't really affect you all in Canada, but we just saw our first batch of V5 batteries roll out of the Vietnam factory. We're expecting V16, that's that 16 kilowatt-hour outdoor wall mount resi battery towards the end of this year. And then hopefully around that time or early into 2027, we'll see our commercial batteries coming out of the Vietnam factory as well, or at least a portion of them. So the Pytes team for the Americas, it's got three main divisions: sales, product team, that's me, and our fulfillment team or logistics. One thing I love about Pytes is there's not much of a hierarchy between those three divisions or those three teams, if you will. So you can usually, talk to somebody in sales and get product questions answered, or vice versa. Ask somebody like myself or Joseph from product side, and we can give you some input on sales. But at the end of the day, everything we do is very customer centered. And then I also think we do a really good job of continuous improvement, right? So like every new product that we make is a little bit better than the last, right? We really do love getting feedback from our customers, our installers, the people in the field that are actually putting our solutions in operation, and we use that feedback, to its fullest to make, the next version or next iteration of that battery even better. But we're also very responsive. We've got full-time staff that live in the U.S. along with our team in China, so you can always call us and speak to a real person. A couple shots of our team there at some expos recently. And then at the end of the day, we are a battery manufacturer. We do not make inverters or PCS. And so what that means is I like to say we're inverter agnostic, meaning that we can partner and we're compatible and we're certified with a number of different industry leading inverters out there. So I'm sure a lot of these brands are familiar to most of you. These are actually all brands that Charge Solar offers, with the exception of Mega Revo and GoodWe. So yeah, very, very wide-ranging compatibility across the board. So being that Pytes, we are again an OEM, which for me is a huge differentiating factor when you look at us compared to some of the other battery players in this space, where a lot of them are using a third party or contract manufacturer overseas. At the end of the day, we know we're not the only company making batteries in this space, and we obviously understand that people shop around and make sure they're making the most educated decision they possibly can when they're purchasing a battery. It's a big investment, so you got to make sure you do your research, right? So this is a little graphic I like to show to kind of prove that point, that um, there's a lot more going on inside of a battery than you see uh, uh, above the surface, if you will. So my iceberg example, right? An iceberg you see floating out on the sea. Well, the majority of that object is under the water and you can't really see it, right? But you can see a little bit peeking up above the surface. And so let's equate that to energy storage. When you're shopping around, you're looking at other batteries, right? There's a few things that I think are very obvious and very well advertised, if you will. Okay, so one of those is obviously price. That's a huge factor for some people, maybe the most important thing. I don't think we try to be the lowest sort of bottom of the barrel in the pricing world. That's not really our strategy, but we're also not the most expensive. I think we're pretty competitive if you start looking around a little bit, but another thing, right, is the basic specifications of the battery, right? Pull up a data sheet. You have a call with your rep at Charge Solar. You guys can very quickly, I think, and easily go over the battery specs, kilowatt hour, power output, size, weight, etc. And then the third thing there, that's kind of my tip of the iceberg, if you will, are some standout features of batteries like fire suppression or remote monitoring. Sometimes those are very well known, right, without digging too deep. But to make a truly well-educated decision when purchasing a battery, I think you do have to start asking some deeper questions, right? You've got to sort of dive down under the surface and see what's underneath the water, if you will, because often we're just looking at the tip of the iceberg. So some of those things that are super important that I think really differentiates us from the competition are what we see below there. So one of those I hinted at already is service. We've got local teams, bilingual support, English, Spanish, trilingual if you count Mandarin. I don't like to say 24/7 availability, but round the clock. So given that we have a team in the Americas and a team in China, doesn't really matter what time of day you're contacting us. We're going to get you in touch with somebody who can assist you, and we try to make that response time as fast as we can. Another important thing that is a little bit hidden, I think, in some ways, are the cells in the battery. So, we only use the highest tier, highest quality lithium iron phosphate cells. We've spent decades now developing these partnerships with some of the biggest lithium cell manufacturers in the world, and that lets us not only get the best quality possible, but it helps us keep our pricing very competitive as well. The BMS is super critical too, right? You could have the best cells in the world, but if your BMS sucks, that's not a good battery, in my opinion. So, again, given that we've spent over 20 years now developing our own BMS technology, making sure it properly protects the cells inside the battery and everything else. You can talk a little bit about the structure of the unit, how the pack is put together, how things are wired, are there other sort of safety features in there, gets you to hardware protections, things like pre-charge circuits, current limiters, extra overcurrent protection like breakers or fuses. So really, we try to consider all of these factors to uh, make the best, holistic product that we possibly can. So today, again, is all about commercial energy storage. I realize this is not Canada, but really here I'm just trying to convey the concept of why this makes sense for commercial applications. So I think we're, at least for commercial, right, the days or this concept of like 100% energy offset covering every kilowatt hour you consume in your bill, that doesn't really make sense. But what does make sense is going after these peak demand charges, right? So a lot of commercial properties out there, and not just the US, but in Canada too, they have peak demand charges, right? So that can sometimes account for, 30 to 70% of a typical CNI bill. And it basically just means if you're using, above a certain amount of power, you're going to get hit with this extra charge that can be very, very expensive, right? Obviously you can see in the States, right, there's a very pretty dramatic variation in the number of customers that are subject to these demand charges depending on the state. And Canada is just the same depending on the province and municipality even. You could see different demand charge rates across the country. So again, it's all about going after that peak when you're having sort of an initial call with the customer, and they tell you they have these demand charges. If it is $15 a kilowatt or higher than that, then energy storage can really make a lot of sense, right? And again, we're not here to cover the entire load profile, but maybe we're just trying to shave this peak off so that we can reduce those peak demand charges. So again, kind of the best fit is that $15 per kilowatt. A lot of the peaks are short and repeatable. They don't last for very long. Some of these loads that cause peaks are big inductive loads like pumps, compressors, HVAC systems. So things that are sort of, cycling on and off throughout the day. And when they turn on again, they cause that big spike in the load profile. So a lot of times adding the storage, we can really lower those demand charges without, changing how the site operates or even doing a lot of rewiring on the AC side. It just basically means their bills are a little more predictable, and they can maximize that solar self-consumption and the energy storage as best they can. Now, if you're going after a customer that is interested in commercial energy storage, right? If that load profile is really flat, there's not many peaks, or they have a peak that is, I don't know, basically the whole day, or even if they're not really able to give you any sort of interval data or specifics on how those demand charges are affecting their bill, maybe the batteries might not be the best fit for that customer. Right, of course, there's going to be many commercial systems out there that don't have peaks, or for example, they're off grid, or maybe the grid quality is very, very poor, or they want battery backup, right? Those are all other reasons you can incorporate energy storage for CNI. So we'll get into kind of our product lineup in a bit here, but right, main takeaways, we've got several different commercial battery options, both for indoor and outdoor applications. Everything we make on the commercial side, actually really similar to our resi stuff. It's all very modular. So, that's another thing. If you're shopping around, you're looking at the competition in the CNI space, a lot of these other companies are giving you, sort of like one or maybe two different kilowatt hour sizes, and that's all you have to pick from. So with us, you can actually sort of piece together your system a la carte, if you will, and scale up or down that energy capacity as needed. and everything we make is also, fully certified to UL 9540, 9540A, 1973, obviously, and then with our outdoor cabinets at least, we have NFPA compliance as well there. So that's kind of the why to do energy storage for commercial applications, with or without PV. So we'll go into now a little bit more about our lineup and introduce the products that Pytes offers. So I like to take a sec to go back to basics a little bit, if you will, and sort of highlight the main concept behind, commercial energy storage. So when I say that in the context of today, specifically what I mean is we have batteries that are connected in series for a high voltage system. So a lot of our high voltage batteries are actually the same capacity as our low voltage batteries. These are V5 at the top. This is our HV48100. The modules are 5 kilowatt hours both ways, but what changes is the connection method. So for low voltage or most residential systems, we always connect in parallel, right? We're maintaining that 51.2 volt nominal across the bus. Um, Commercial or high voltage systems difference, the opposite. We're connecting those battery modules in series. So my main point though is there's a lot of benefits in using high voltage batteries for commercial applications, but it's not like we're magically creating energy out of thin air and it becomes, better just inherently, right? If you have the same amount of batteries at the end of the day, six modules, your energy totals are identical. All that we're changing is our voltage and our amp hours. So I also want to stress that right, we're not locked in here to where you always have to use high voltage batteries for a commercial site, or you always have to use low voltage batteries for a residential site. They're very much so interchangeable. And at the end of the day, it really just depends on what's best for the application. So there's crossover for sure. But today, again, we're focusing on high voltage that's specifically intended for CNI type systems. So kind of another reason why we're using the high voltage for commercial instead of the low voltage is, the higher voltage means lower amps. So that, of course, means smaller cable size. I think, in a sense, less risk. It's a little safer in some ways. Uh, that also lets us produce more power. So it's just a lot easier to scale up and match with these commercial inverters. And it simplifies the BOM as well. A lot of the commercial systems need three-phase power, so you can often use one commercial inverter that gives you a three-phase native output. Whereas if you look at residential inverters, typically you're having to stack uh, at least two, often three inverters to get a balanced three-phase output. So again, simplifies the BOM and I think reduces the supporting accessories quite a bit as well. So some kind of pro tips for me, if you will, about installing these high voltage systems. They are uh, different enough than the low voltage resi side batteries to where there's a few things you want to be aware of. My biggest one is this extended storage before commissioning. Given that the batteries are in series, they have a much more difficult time balancing compared to when we have a parallel install. So you want to make sure that you're planning your ordering and your installation accordingly. You want to check the manufacturing date on the batteries, make sure that we are recharging those batteries every 6 months. If not, that can lead to some kind of annoying balancing issues when you go to do your install. Of course, you want to read our manual and all our documentation. We make that stuff for a reason. There's a lot of good info there, so that's my read the freaking manual reminder for everybody out there. Not doing firmware updates or skipping the remote monitoring setup. That's really, really important for me too. When we deploy these systems, when you do your commissioning, You want to take that extra time to update the firmware, both on the battery and the inverter side, to the latest version. I mean, I think that's best practice for any system, commercial or resi. But you want to make sure you're prepared to do that update either on site with a laptop and our console cable, or if you can connect the batteries to the internet, just like the inverter, often we can do that update remotely. So this one's super important. I mean, I know it kind of seems maybe not as critical as getting the system turned on and going, but right, we want to make sure it's going to work and not have any issues long term. So, take that extra little time at the site to get those tasks completed. And then this one's a little more minor, but just simple things like labeling the cables. A lot of these high voltage inverters have two battery inputs. And so you can imagine you've got two cabinets connected to one inverter. I've got some examples on that coming up, but you just label everything, take that extra few minutes, label the power cables, label the comms cables. I can't tell you how many literally hours I've spent troubleshooting a problem to where we find out somebody just flip-flopped the BMS cables at the inverter. So again, sounds really trivial, but helps save a lot of headache too at the end of the day there. My biggest recommendation is just reach out to us. We do this stuff every day. I realize, especially here in the States, right, we're starting to see a lot of installers transition from residential installs to commercial. So there's a bit of a learning curve. There's a lot of new stuff to stay on top of. And ultimately, at the end of the day, if you have questions, concerns, doubts, problems, reach out to us. We're happy to help. You can email us, you can call us. We have availability on WhatsApp as well. And again, with that combined Chinese and America's team, I should say, you're going to get a response from a human as soon as we possibly can. So a few more resources. We'll make sure Charge gets a copy of the slides to share with you all, but we've got some really good videos, I think, out there that explain some of what I just went over, but in more detail, and then introduces you to some of our different products as well. So you can kind of see it, live, if you will, and get a sense for the size and the scale of the batteries. More resources as well, just different integration guides and our manuals. These are all available for free download on our download center. And so now we'll kind of go into product specific stuff. This very first model I'll introduce, this is our HV48100. As I said earlier, right, the modules are 5 kilowatt hours, just like our V5 battery, but what changes is the connection method. We're connecting in series, not in parallel. So I want to take a quick moment to introduce these two components here, the BCU and our BMU. These are the two main parts of the high voltage architecture, and this is actually pretty standard for other battery companies as well. But basically, you have your batteries, right? The battery module units, they're what holds and discharges energy. It's a battery, right? They're very basic. You can see there's not a whole lot going on. Positive, negative, a couple communication ports, little indicator light. Most of the action is going to be happening with your control unit or your BCU. So you can see, we'll see better later, but that is usually at the top of the cabinet or at one end of the battery group, if you will. That's the user interface. This is how you're turning the battery group on and off. This is the thing that's controlling all the batteries. This is the thing that's talking to the inverter. There's no cells in this piece. It doesn't have, doesn't hold or release energy. It's just sort of the master controller for the group where all your cables connect to. This first solution is indoor rated. All these cabinets are indoor only. The batteries themselves have a half C rating. So right out of the 100 amp hour capacity, we can charge and discharge continuously at about 50 amps or about 2.5 kilowatts, backed by a 10-year warranty, 6,000 cycles at 90% depth of discharge. And then depending on the cabinet model, you've got different energy capacities available. So again, these are all indoor cabinets. And you can see we've got a few different options. This is an 8S, so 8 batteries, that's 40 kilowatt hours. This one's 12 modules, that's 60. And then this one is a 15 module cabinet, which depending on the inverter you're connecting to, you could actually have two groups of batteries or just one longer group in series. So this 12S1 is really interesting for me because it does give you, I think, in terms of everything we offer across the board, resi and commercial, like this is the most energy that we can provide you in a single footprint, if you will. So given that it's all 12 batteries stacked on top of each other, compared to just eight here or this one, which is two columns, right? So it's going to take up more floor space. This is what's going to save you floor space in your room, in your shipping container, et cetera. You've just got to make sure you have the height available to put this tall one in there. But again, indoor only. And I also want to make a point here that none of these have any kind of fire suppression, fire detection, smoke detectors. These batteries do not have heating pads inside. There's no fans, there's no air conditioners. So when you're doing a design and you're looking at these, just make sure you have done your due diligence and you've confirmed with your AHJ exactly what they want to see. Because if you put these in and then later on you found out, oh, we actually need NFPA compliance, we need aerosol suppression, we need a sprinkler system, et cetera, right? None of these solutions have that. At the end of the day, these are somewhat basic batteries, but very, very well proven in the industry. I think we've got, well over 10,000 units, 50 plus megawatt hours deployed in the field operating. So this is a product that's been out for a couple years now. When it comes to configuration, this is a big difference between the resi and the commercial stuff is that we are connecting the batteries in series. So we need to make sure we have the minimum amount of batteries needed for our equipment, which is that control unit, and the inverter's minimum battery input. But you've also got to be careful that you don't have too many batteries in series because then you're actually going to exceed what the inverter can safely accept. So these are just sort of the possible ways that you can configure the high voltage batteries depending on what inverter is being used. Today I'm focusing primarily on Solarc and Solus. Those are our two main inverter partners and two brands that Charge Solar offers. So you can see here, right, some of the models with the lower input voltage of only 500, we can only do about 8 batteries in series. The new Solus commercial hybrids are pretty nice because they have an 800-volt limit. We can go up to 14 batteries in series. And then our Solarc 60K is kind of right in between. That's 12 batteries in series as a maximum for that unit. So this indoor solution, I think, is it's actually really plug and play. So you can kind of see here with the bill of materials how simple it really is. Ordering these components, you get everything that you need. One to connect the batteries together inside the cabinet and then connect that completed cabinet up to your inverter. So remember the batteries have a half C rating. So imagine you've got one cabinet that's 40 kilowatt hours. It's going to output 20 kilowatts. In this case, if it's connected to a Solarc 30K, that's not quite enough to satisfy the inverter's maximum power output, right? It's only 20K compared to the 30 rated. So how do we unlock more power? How do we meet that 30 kilowatts that the inverter wants? Well, it's just as simple as adding another battery cabinet. Notice how the BOM doesn't change, basically just doubles your quantity. So here, again, where we have the same 40 kilowatt hours in each cabinet, but now we've got two of them to give us 80 total. Technically, these two cabinets together can give you, half of that in power output, 40 kilowatts, but because we're connecting it to an inverter that's rated for 30, in this case, the inverter is the bottleneck, if you will. So technically you could do like a 6 battery setup in each cabinet and still meet that 30K. But again, my main point here is how easy it is anytime you can stick to that, what I say 1-to-1 or 2-to-1 battery to inverter ratio. Anytime that's possible, I highly recommend doing that. So similar example with Solus, all that's changing is we're doing 12 batteries in series instead of 8, because again, the Solus has a slightly higher input than either of the Solarc models. So the concept is identical. It's just a 60 kilowatt hour cabinet instead of 40. And then again, if you need that full, 60 kilowatt AC output from the inverter, you just need two cabinets, and your BOM still stays simple. You just have to increase the quantities, basically. Of course, we can scale higher than 1 to 1 or 2 to 1. That involves a few accessories, being our high voltage combiner box, our hub, and that's going to let us do systems much, much larger than what I was showing. Depending on inverter manufacturer and depending on your battery series quantity, could get us into the 3 or 4 megawatt hour range. But yeah, basically we can support up to 6 cabinets per inverter, and then both Solarc and Solis say that you can have up to 10 inverters paralleled on the backup side. Now, if you need a system larger than that, you can have infinite inverters theoretically, as long as they're not connected in parallel on their backup side. So what I mean by that is the inverters can be paralleled on the grid side uh, to any quantity you need. But if we're doing backup power, we've got critical loads. That's where that 10 inverter max comes into play. So Solarc, Solis, again, those are two uh, main partners in the commercial space. We are fully certified and listed with both, and both inverter companies have us included in their integration guide and their compatibility lists as well. So switching gears a little bit, this is a newer model. This is one that we just rolled out earlier this year, our HV48100 SE. So now this is an outdoor rated cabinet with a bunch of additional safety and protection features. The similarities, though, there's a lot. It's still batteries plus the control unit. The batteries are still 5 kilowatt hour rated with the half C rate. The warranty is the same. So what I'll focus on this model is really just the cabinet, right? We can see it looks very different than what I showed before. It's got a 5 level fire suppression and detection system. So in here, you've got smoke detectors, gas detectors, aerosol fire suppression. There's visible, audible alarms, ventilation. There's a heat pump on the outside that does heating and cooling. The modules themselves are a bit different in the fact that they have heating pads, they have cooling fans. The cabinet as a whole is IP55 outdoor rated. Also has a high degree of anti-corrosion coating. So this would be something great for coastal areas or marine environments where, maybe it's subject to high humidity or salt spray. So a couple more examples on configuration. Again, this is really similar to the indoor model, but just goes to show how relatively simple I think it is to do these designs. But again, kind of goes back to that half C rating. So, for example, if you've got a Solarc 30K, we can't connect more than 8 batteries in series, but let's say we want to hit that 30 kilowatt rated output. Well, you can do what I say, a 6S2P configuration, which means 6 batteries, but in 2 groups. And that's going to give you the full 30 kilowatt rated output. On the 60K Solarc, we can connect more batteries in series. So you'd use a 12S1P configuration instead. That's 12 batteries as one group. And look at the similarities, right? Both it's the same amount of energy, both it's the same amount of power. So again, to unlock that 60 kilowatts from this inverter, you just need to have 2 cabinets, one cabinet to each input of the inverter. This one, it's just one cabinet, but there's actually 2 battery groups, or more specifically 2 control units inside that still satisfy both of those inverter inputs. And this is just a more detailed example of that, where you can see very simple BOM. This is sort of the internal layout in the cabinet, if you will. Group 1, Group 2. That's a Solarc 30K. The inverter can mount on the side of the cabinet directly. Same concept for the 60K, except we need 2 cabinets again to hit that 60 kilowatts. But yeah, inside the cabinet, you've got all 12 modules in series for your 60 kilowatt hour capacity with just one single control unit. All those concepts apply to Solis too, but actually I almost think the Solis designs can be a little simpler because, again, all of their inverters, 30K, 40, 50, 60K across the board, they all have this higher input voltage of 800, which means we can do 12 batteries in series for any of their models, and actually we can go as high as 14. So, kind of another example there with Solus, very simple BOM inverter can mount right on the side of the cabinet. And if you need more than what one cabinet can produce, you just have to add a second cabinet, and then that basically doubles your power output. So again, sticking to that 1-to-1, 2-to-1 ratio, that is maybe my top recommendation from those last few slides. It really just makes everything easier and simpler across the board. Uh, More cost effective as well, right? Because you don't need accessories, you don't need this combiner box, but we can scale higher than what I showed earlier. This is something that's actually still in development, so we don't fully support this yet. But in the next 4 to 6 weeks, we should have the necessary firmware from our headquarters needed to do this. So I think, if you've got a project that's still some ways out, I have no problem designing a system based on this, but any immediate installations, stick to that 1-to-1 or 2-to-1. And again, this is just the outdoor batteries. The indoor batteries I showed earlier, they don't have any, those are scalable up to 3 or 4 MWh today without any wait time, basically. So the last member and newest addition to our commercial lineup is a higher capacity version of the outdoor cabinet that I just showed. So this is our HV48300 Max SE. And the big difference here is that the battery modules are 16 kilowatt hours each. So we've moved on from this 100 amp hour cell form factor into a 314 amp hour cell, ultimately giving the cabinet a much higher capacity. The power output or the rating on the battery, it's still a half C, but you can see, right, one module at 16 kilowatt hours gives you 8 kilowatts of power in and out compared to just the 2.5 from the other. Aside from that increased capacity, really almost everything in the cabinet's the same as that previous option. In terms of the outdoor rating, IP55, it's got corrosion protection, all the certifications, all the listing, all the fire protection equipment. It does have this large distribution box on the side. So like the inverter would normally mount right here. And then inside this box, which is already attached to the cabinet, that's where you have all your connection points, your AC wiring, your DC. So that's another thing that was added basically. This one is still in development. We don't have these in stock yet, but we're hoping sometime later this summer they'll be available, and then expected completion on our certifications, I believe, is October. So this one is still a little ways out, but we are, designing systems around this model, and I think this one's going to be quite popular given the higher capacity. But yeah, kind of the same thing going on inside. Like I said, fire detection, HVAC system, heat pump, aerosol fire suppression. That's all built in. This one actually does not have heating pads. Being that the modules are higher capacity, they're going to, I think, thermally regulate themselves a little bit better than the 100 amp hour model. So just keep that in mind. But again, the heat pump on the front can help control the temp in the cabinet. Touched on this already, but mainly just, again, that increase from the 100 amp hour format to the 314. These 314 cells is actually what we're employing as well in our V16 residential battery. So this seems to be, sort of an industry trend, not just Pytes specific, but higher capacity cells. They're going to be more efficient, have a longer lifespan, and then ultimately the big one is they're more cost effective. So these 314s are manufactured in such a grand scale for, utility grid scale type projects. So the supply is, I think, very, very stable now with that increased size. The module voltages though are still 51.2. So, in terms of like the number of batteries in series as a min and max, that's all the same. An example with Solarc 60K, again, 500 volt max input. That means we top out at 12 batteries in series. 12 batteries at 16 kilowatt hours apiece is almost 200 kilowatt hour total, which again, no issue satisfying that full 60 kilowatt output of the inverter. And I'm not showing it in this specific example, but there is actually a bus bar in this distribution box that lets one control unit uh, fill or connect to both of the inputs on the inverter. So basically, we're allowing you to get that full rated charge and discharge current out of the inverter to just one battery control unit. Solus is not much different. The only thing that changes is we can connect up to 14 batteries in series. Still plenty of capacity there to hit our 60K rated output. But given that there's 14 batteries, it's going to be closer to 220 kilowatt hours total. So those are kind of the our three main products for commercial right now. You can kind of see the progression between the models, and what for me is fascinating to point out is just look at the time scale, right? That indoor option is already a couple years old, 2 to 3 years old now. We released the outdoor, the middle option at the end of last year. And then already in 2026, right, we've got this higher capacity model coming out too. So that goes back to sort of installer feedback and that continuous improvement concept. But you can kind of see like, each version of this cabinet or solution, if you will, gets better and better each time. Um, Both of the outdoor cabinets, again, have full NFPA compliance and UL certifications. Kind of an overview there of the HV48100 SE, where the different fire control and protection components are located. Those certifications apply across the board to all of our products, and we actually are waiting on the newest edition of 9540 for our indoor model, which means it'll be even more compatible with some of the commercial inverters that Charge Solar offers. So a little bit of our C&I roadmap. This one is available. We have these in stock in the US. We've got a couple installations that were just recently deployed of our HV48100 SE. That higher capacity 48300 Max is coming later in the year. And then we're actually working on developing an indoor version of that higher capacity battery. So again, these are 16 kilowatt hour modules, but without the sophisticated and correspondingly expensive outdoor cabinet. So this is like a really uh, much more cost-effective option with that higher capacity. But again, no NFPA, no fire suppression, no heating and cooling. So make sure you're considering those factors. That this is still a ways out, like I said. But yeah, maybe later this year, could even be early on into next year. So I do have a few case studies. I think if we've got time after Q&A, I'm happy to go back through these and show them off a little bit more. You guys will all get copies of the slides too, so you can check them out on your own. But I just want to get to kind of my last section so we save some time for questions. And that is our Certified Installer Program, or Pytes Power Partners. This is something we've rolled out in the last couple years, and honestly, I encourage anybody who has installed Pytes or anybody who wants to install Pytes to scan this code, sign up for this program. It is totally free to sign up. We will give you up to $300 US for a new sign up. We also have a system for quarterly rebates, yearly rebates. Why to join this program? Ultimately, it gives you not just those rebates, but we do work with our certified installers on sales leads and co-marketing. It just helps us connect us to potential customers in your area. Basically, we've got an internal map in Pytes that we can look at and see, where all of our installation partners are located. And again, that lets us connect potential customers to you. You do get some maybe slightly elevated service and support, at every stage of your project, excuse me. early access to updates, new releases, new products. But the training portion again is a big thing for me. So any of our Pytes Power partners, we do typically do a quick onboarding call, a quick training to learn more about you, what your projects are like, what your needs are. We do webinars all the time, just like this with our distributors. We also do, public webinars of just Pytes. And then you will also receive an official uh, Pytes Power Partner certificate that you could share with your customers or, have available to, I think, really, instill confidence with your customers that you are certified with Pytes. And, I think that can mean a lot in some cases. So, again, highly encourage everybody watching, scan that code, sign up. I'll have it again at the end. So if you don't catch it this time, no worries. That's just some details about the rebates, but we are doing now uh, like case features. So, you guys can submit installations to us, and if it's, the case of the month or even like the install of the year, you have an opportunity to get some money back and sort of win some cash, if you will. But yeah, a couple examples below there of your certified installer certificates. And then rounding it out for me, I honestly don't know how relevant or widely used WhatsApp is in Canada. I know it's not super popular in the US, but for our Latin American team, I mean, it's almost exclusively WhatsApp. So that for me it's important. There's many companies out there, inverter and battery companies, that won't talk to you besides email, or you have to call them on the phone. So again, this is just another way you guys can get in touch with us. You can get that direct support. So this QR code will actually take you to our WhatsApp community where you can, communicate with other installers, with us, and then also just stay up to date about everything new and, the latest happening with Pyte. So yeah, you're welcome to scan that one too if you are a WhatsApp user. That's a good one to have as well. So I know I sped up towards the end there just to save some time for questions. Like I said, if anybody wants to look at the case studies, we can definitely do that. But I will stop there. That's our Pytes Power Partner code again for anybody who didn't get it earlier. But yeah, I'd like to say thank you all for attending today, and especially thanks to Charge Solar. It's always a pleasure doing these trainings with you guys and just working with you guys in general. So I think now we can save a little time for questions.
Hey Logan, one of the ones that was answered via chat, but I thought it might be interesting to dive into was how the inverters pull across the battery stacks, whether it's evenly, whether you can prioritize or any of that sort of functionality across it when they're paired with like a Solarc 30 or 60 across is that the inverter has that intelligence, or is that the battery stack that has that intelligence level?
So do you mean, let's see if here we go. We can kill two birds with one stone here. So do you mean if you've got two battery cabinets connected to one inverter?
Uh, sure, we can use that as an example, but
Okay.
even if it is all in just one string of, let's say, 14 or 12 with the inverter, but
Yeah,
cover both scenarios.
sure. So I'll kind of answer that in two different ways. And this is actually a really good point too. So when we do these high voltage systems, we do not recommend installing these in open loop. Okay, so open loop is, again, there's no communication between the batteries and the inverter. That method of open loop without communications is maybe not so much these days widely used, but definitely widely acceptable in the residential world where we're using low voltage batteries. The high voltage batteries, given that different connection method, they're a lot more sensitive to things like over voltage, under voltage, and that nature. So, like sometimes, even if there's one battery module in the stack, or even just one cell within a module that goes over temp, under voltage, etc., it knocks out the whole stack. So when we do these high voltage systems, kind of the first part of my answer is we always have communication. That's basically a requirement in this case. So you have the BMS inside the batteries directly communicating with the inverter. So in other words, you program your inverter to, or I should say, you program the inverter when to discharge the batteries and how hard or how fast, right? But at the end of the day, it's the BMS that is providing those limitations to the inverter. So, you know, the question of like how do the batteries charge and discharge with the inverter, that's all controlled by the BMS. Again, you're going to input settings on your inverter to match your application. But at the end of the day, it's the batteries that are in the driver's seat, if you will. So say you program something wrong, or like say the batteries get discharged too far, etc. The inverter is kind of the first line of defense in catching that, but you also have the BMS at the end of the day to act as that extra layer of protection. So that I guess the first part there was sort of like a generic how do the batteries interact with the inverter. More specifically, if you look at an example like this, and I had this up for a minute, so I'm going to use that as a chance to show a different case study. If you have an example like this, right, these are soulless inverters, but notice I've said this multiple times, 1 to 1, 2 to 1, right? Um, for sure, one of my biggest takeaways of the training today. So in this case, which is actually in the Philippines, we've got two cabinets for every inverter, 2 to 1, 2 to 1, 2 to 1, 2 to 1. The inverters have two battery inputs, and this applies to both Solarc and Solus. Now, those battery inputs are completely independent of each other. So we're actually not parallel connecting these two batteries, but each battery cabinet feeds independently up to an input in the inverter. So that means that typically your battery cabinets can, in certain cases, be charging and discharging at different rates. They can have different state of charges. And again, that's because the two inputs inside the inverter are isolated. Now, in almost all systems, once they've been cycled a little bit, right, you're going to see consistency across the board. So like in this example, we would expect all the batteries to basically be running at the same SOC. It's kind of another reminder too here is that you always want to have an equal number of batteries on each inverter input, and I would even stress an equal number of batteries per each inverter. In some cases, it's not required. I know Solus is a little bit more flexible in that sense compared to Solarc, but in my experience, try to keep everything balanced and symmetrical, and that kind of just tends to be, I think, more successful over time.
Okay, we're running up against time, but there's just one last question I'll just pose here from chat, which is, is there an ability or is it possible to have two inverters to one battery stack if you're complying to the, discharge maximum values? Could you, AC stack the inverters into a single battery?
Um, Not right now. So that is the way I understand that. I guess the way I would answer it is it's a little like that. That's more of a limit on the inverter side of things, right? So Solarc and Solus, again, I'm touching on those because that's what we're deploying actively right now. You don't have, or I'll say like the inverters in this system, or let's look at this one too, because this one had, I think, 4 or 5 Solarcs. Each inverter has its own battery bank. So the inverter manufacturers don't want you, and they actually say you can't connect two inverters in parallel on one battery. You can do the opposite though. Like I showed earlier, you can connect multiple battery stacks in parallel to feed one inverter, but it doesn't really work the other way, if that makes sense.
Yeah, that makes sense. And that the command and control is all being done by the inverter, not by the battery and BMS. So that actually makes quite a bit of sense. And then really quick, in a high voltage system, if a battery triggers an alarm or has a problem, will that affect other battery banks in the chain? Like, is there communication, or are they isolated to the one bank as the isolated bank?
Ooh, really good question. Um, yeah, yes and no, from what I've seen. So in let's go back to this one. So again, this is following that 2-to-1 architecture that I keep iterating. If and again, the batteries are independent here. So if one shuts down or has a problem, typically the other group is still operating independently because they're going to separate inputs on the inverter. In a system like this, though, it's honestly really hard to see in the picture there, but I think this system had 3 battery cabinets per every inverter. So now we've exceeded that 2-to-1. And now what that means is we have a some communication management device, which we call the hub, in between every 3 batteries in the inverter. So now what's happening is you've got 3 batteries communicating to the hub, and then the hub, that one single thing is communicating to the inverter. So then you can imagine if one of the batteries has a problem, it's going to report that problem to the hub, and therefore the hub reports that problem to the inverter. And at that point, from what I've seen, that problem is typically going to affect all the batteries. Or sorry, like not, I don't mean that in the sense of like a fault on battery cabinet one affects battery cabinet three, but because all the comms from all 3 cabinets are being aggregated, if the inverter sees an issue with the communication that's coming from the hub, it's basically going to the inverter would have a battery fault preventing it from using any of the 3 cabinets. Maybe that's the best way to say it. So yeah, it just depends. But I think again that 1-to-1 or that 2-to-1 design ratio, it just makes a lot of sense anytime you can do that. So that would be my main recommendation anytime it's possible.
Okay, it does look like we're at time, and there aren't any active questions. There were a bunch that were answered live through the team. So I want to thank you for putting on this presentation. Tatum, do you have any final remarks?
Yeah, I was just going to thank Logan for your informative presentation. Thank you to everyone who joined us today. This webinar recording will be added to our YouTube channel, which I'll just pop into the chat for you there. I'm also going to email you the recording by the end of day today. So thank you again, everyone, and have a great rest of your day. Thanks, Logan.
Thanks, everybody.